sub f, so it's 4. This guy, remember, this is not t sub f, this is just t. The initial velocity has been going since our t0, going the whole time. So that's 7. And this is all meters. I just evaluate this out. This one coincidentally ends up, just with the way the numbers work out, doing the integration of the fact that it's 4 seconds. It ended up still being 42. This is just sort of a coincidence, no special anything happening here. So, this is 32K for this portion. The 4 to the third is 64, so half of that is 32 plus 55.43J plus 7 times 80, 560I. This is all meters. So again, combined terms, we get 74.67K plus 55.43J plus 560I, all still meters. So that's the position vector at t equals 7 seconds. So I am going to now be erasing things so I can do my dot products and find my angle. That's basically what remains. So, as I said, it seemed like, although I haven't graded it, it didn't go so high.
So are you grading us on how much ours looks like this, or like if our answer like kind of makes sense? Because if you look at mine, I mean, theoretically it's sort of right. I mean, it follows.
This is why grading's a nightmare. It's sort of all that. I mean, yeah, I'm going to look at it and I'm going to see.
It's like the steps make sense, but they're
yeah. So if your steps make sense, if I can follow what you did, that's a huge plus. Like if you have work that is too confusing for me to understand, you know, it's hard for me to give too much credit for it.
That one is so smart.
So if I get well, you gotta bring it down to my level. So, all right, you gotta bring it down to my level. And some of it's handwriting and neatness and laying it out. You know, you lay it out decently on a page, and I can read what you've written. That certainly makes life easier. So, I mean, the first thing I do whenever I grade a problem is to try and understand what did this person do. I mean, if they did it right, then it's easy, and that's great, and I love that. But if they didn't do it right, then I have to try and. So, the first step is trying. I mean, yeah, it takes me a while to puzzle out. I might spend a while puzzling out, like, what were they doing here? So then I can figure out, okay, which sort of what screw up did. Once I've understood what they did, then I start to okay, where did they go wrong? How much am I going to ding them for what they did wrong? That's kind of how I go at it. So
you plug in 4 seconds before you integrate it all the way to position.
What's that?
Like you solve that acceleration at 4 seconds.
You know, just call it 16. Then how do you integrate it? Or whatever. We got this one right here. So 4 seconds, 16 to 32. I mean, that's true. That is the acceleration at t equals 4, but it's not the acceleration the rest of the time. When you're doing integration, the whole idea is sort of area under the curve. You know, and so it's varying. At the beginning, this acceleration is 0. I mean, this acceleration is right. So we have t. This is t, and this is the acceleration. This is a2. It's going to perk along at 0 until we get to 3, and then it's going to go up as an exponential. And so, yeah, at 7 over here, we can say that this value is 32. You can't just like use 32 the whole way along. So the area under the curve. And the area under the curve is your velocity. This area is your velocity. And integrate that again in this position. That's how those integrations work. So no, I wouldn't say you can evaluate it at the beginning. If you do that, you have no, you're not going to integrate. It wouldn't work. I mean, so if you had it right here, this is 32. So I integrate here, and I just throw a t on it, right? So I go to here and I have 32t. That's not the same thing as this function. This. And I do it again, I have 32t squared over 2, I guess. Again, it's not the same value as this. You can't do that. have to be the initial velocity vector. It just has to be moving in the same direction as the initial velocity vector. Okay? Doing angles. If you're doing the angle between two lines, it doesn't matter how long the lines are. It just matters the direction they're going. Does that make sense? And so for that reason, I can take the dot product of this, instead of with the ADI, I can just take it with I. Just take the dot product of that with I. Because I is going in the same direction as the unit vector. The dot product of that with I is trivial. Yes. If you're 560 over 567, and you end up with 9.43 degrees. And you could also have done